All right, let's just dive right in. You know, if you were to walk into literally any university physics department around the world and just whisper the name IRODOV, you'd instantly see a very specific reaction. It's this wild mix of deep respect, nostalgia, and, frankly, a healthy dose of residual dread. Today, we're exploring a book that has achieved absolute mythical status in the STEM world. It's not just a textbook, guys. It's a rite of passage. We are looking at Problems in General Physics by I.E. Irodov, a text that has literally pushed some of the brightest minds on the planet to their absolute limits.
So, here's our roadmap for today's explainer. First, we'll look at the ultimate physics challenge. Then, the origins of a masterpiece. Next up, mapping the physics universe, followed by Irodov's rules for success. And finally, we'll be facing the first trials. Let's get to it.
All right, Part 1, the ultimate physics challenge, meeting the legend.
To really understand why this book is so legendary, you have to realize it's widely considered the Mount Everest of STEM education. It is an absolute gauntlet. It doesn't teach you physics with gentle, easy-to-read paragraphs of exposition. Oh no, it teaches you by throwing you straight into the deep end with weights attached to your ankles. Just look at this iconic retro cover. That stark orange and black aesthetic with the minimalist diagram of a spiraling particle, yeah, that instantly triggers memories for anyone who's studied advanced physics. The whole thing just feels heavy with the promise of the intense intellectual labor waiting inside. 1900. Yep, that is the massive number of grueling, multi-layered problems standing between a student and true mastery of the subject. And listen, these aren't your typical plug-and-chug high school questions, not even close. Every single one is a carefully constructed puzzle, specifically designed to test the absolute limits of your conceptual understanding.
Moving right along to Part 2, Origins of a Masterpiece, the Architect and the Forge. To fully appreciate the weight of this challenge, we really need to meet the mastermind behind it all and understand the incredible machinery that brought his work to the world. So, this is Igor Evgenyevich Irodov. Looking at his credentials, he was a candidate of sciences in physics and mathematics and a professor of general physics. But you know, he wasn't just a researcher tucked away in a lab. He was deeply invested in the pedagogy of physics. He wrote several manuals, sure, but it was this specific compilation, honed over years of teaching at the Moscow Engineering Physics Institute, that became his undeniable masterpiece. He meticulously crafted these problems to bridge that massive gap between basic lectures and advanced world-class scientific research. But how on earth did a single professor's problem set from Moscow become a global phenomenon? Well, the answer is mere publishers. This was a state-sponsored publishing house tasked with spreading leading Soviet scientific and technical literature across the globe. And they didn't mess around. They translated texts into 25 different languages. Their skilled staff maintained incredibly high translation standards, which is exactly how Irodov's work got adopted by top educational institutions everywhere, from India and France all the way to Brazil and Syria. Which brings us to Part 3, Mapping the Physics Universe, the Blueprint.
So what exactly is waiting for you inside this legendary book? Just taking a look at the table of contents reveals an immense scope. It's essentially a blueprint of the entire physical science universe. Part 1 kicks off with the physical fundamentals of mechanics, and then we dive into thermodynamics and molecular physics, electrodynamics, oscillations and waves, optics, and finally, Part 6 wraps the whole thing up with atomic and nuclear physics. This single volume actually dares to map out nearly everything an undergraduate physics major needs to conquer. But get this, it doesn't end with just the problems. The book includes 30, yes, you heard that right, 30 appendices at the back. We are talking about basic trigonometrical formulas, common logarithms, huge tables of astronomical data, and even Mendeleev's periodic table. Why? Because these problems are so incredibly complex that they're practically impossible to solve without extensive real-world reference data. See, Irodov didn't want you to just learn the theory, he wanted you to calculate reality. All right, Part 4, Irodov's Rules for Success, the Master's Advice. Before you even think about attempting Problem 1.1, Irodov demands a very specific, strict methodology. He essentially lays out a 4-step survival guide for us. First, draw a diagram to really pin down the essence of the problem. Second, solve it in a general form. Third, check to see if your answer actually has the right physical dimensions. And fourth, and this is absolutely key, evaluate the plausibility of your numerical answer. He actually points out that if your math says a man threw a stone a distance of 1 kilometer, or if a body somehow surpasses the speed of light, well, you've definitely made an error. It's a brilliant practical reminder to never let abstract math blind you to physical reality.
Now, the most crucial point is embedded right here in his rules. Irodov explicitly insists solve each problem as a rule in the general form, that is, in a letter notation. He so desperately wants to break students of that bad habit of immediately plugging in numbers. But keeping the problem in letter notation, meaning using variables all the way down to your final equation, you actually reveal the true underlying physical relationships. You get to see exactly how different factors influence the final outcome way before a single number is ever calculated. It's a total game changer.
And finally, Part 5. Facing the first trials, entering the arena.
Okay, now that we know the ground rules, let's step into the arena with Part 1. Every section opens with a rapid-fire summary of essential formulas. But notice how incredibly terse this kinematics list is. You've got your average velocity, tangential acceleration, angular velocity equations, and that's it. There's absolutely zero hand-holding here. Irodov expects you to already know what these quantities mean. This is just your tool belt. It's entirely up to you to figure out how to actually use the tools.
And let me tell you, the difficulty ramps up almost instantly. Just take problem 1.7, for example. Two swimmers leave a point on a riverbank to reach a point directly across. One swims in a straight line relative to the shore, fighting the current. The other swims straight relative to the water, drifts downstream, and then actually walks back along the bank. If they arrive at the exact same time, what was the walking velocity? It is such a brilliant illustration of how Irodov takes a relatively simple kinematics concept and morphs it into a mind-bending, multi-step scenario right out of the gate.
He also heavily tests your visual interpretation super early on. Look at figure 1.1. You aren't given a nice, neat equation here. You are literally just given a wavy line representing distance traversed over time. And from that, you have to use this plot to find the average velocity, the maximum velocity, and the exact moment instantaneous velocity equals the mean. If you don't have rock-solid kinematic intuition, well, this simple little curve is going to stop you dead in your tracks.
And then, oh boy, we have problem 1.10. Two bodies are thrown simultaneously, one straight up, one at a 60-degree angle. And your job? Find the distance between them exactly 1.70 seconds later. And of course, Irodov casually tosses in the phrase, neglecting the air drag, just before plunging you into some seriously complex relative motion calculations. To solve this, you've got to set up vector equations and deeply, intuitively understand how two independent parabolic trajectories relate to one another in midair.
And if you thought basic motion was tough, let's just fast forward a few pages to rigid body dynamics. Just look at these incredibly intimidating diagrams. Figure 1.8 shows a solid cone, hinged at its apex, rolling uniformly without slipping over a horizontal plane. And you are asked to find the moduli of the cone's angular velocity and angular acceleration vectors. I mean, it is the absolute ultimate test of 3D spatial reasoning and vector calculus, all smashed together into one terrifying geometric shape.
Which brings us to the end of our journey for this explainer. Ultimately, this book isn't just about finding the right answers, it's really about breaking down your own preconceived notions of just how hard you can push your intellect. So, I want to leave you with this final thought to reflect on. Have you ever faced an academic challenge this formidable? And if this book were sitting on your desk today, would you have the resilience to survive the gauntlet? Thanks for diving into this with me today.